Hello everyone, my name is Joe Scorsone, channel is called Scorsone Enterprises, and in today's video, we're going to be streaming some crypto data and then processing that data to get our own footprint schema for 1-minute bars. We're going to be taking that real-time trade data and aggregating it all into 1-minute bars with a footprint schema on it. We're going to be doing that in Rust with the Binance API, so let's hop right into it. This is my X account if you guys want to know as soon as anything happens with me. It'll all be on X first. Join Delta Gamma Psi as well. It is free, and there will be a Discord coming for that soon. Also, if you guys like to trade the crypto markets, the futures markets, anything, check out my algos I made in collaboration with LuxAlgo. You get this directional prediction. It is a prediction. It uses machine learning, and you get these levels. My face is in the way. You get these levels, which are derived from trying to see where other models' predictions will be, so that way you can know where the liquidity will be. If you follow me on X, you've been seeing that I've been hitting some pretty damn good trades with these recently, all using these algos and fundamental knowledge about markets and options. Use these things to make your life easier. So now let's hop into this code right here. I think that the way that I'm going to be doing my videos from now on is by Control-Zing through them. I can't type and talk at the same time with you guys in the way that, and for something like this, right? I'm either coding or I'm commentating. You know, I don't like to do both at the same time. And I feel like when all the code is just already there, then it's not interactive enough. But so let's go through, right? Because if you guys check out here from Binance, we can get trade streams. So the trade streams pushes raw trade information. Each trade has a unique buyer and seller. So the stream name is the symbol @trade, real-time updates, and this is what our payload looks like. So we need to make a data structure that can store this kind of data. That is what we're going to be doing in Rust, and then we're going to be doing some processing on that. So this is what we're going to be working with right here. I saw somebody else working with Binance's API like this, and I saw it in a GitHub repo. I just thought it was cool. I thought it was a good way to do it. So the link to their repo will also be in the description. So yeah, we have the same schema that Binance is going to give us right here, so that way we can easily map the data. And we're going to be using Saturday.json, so really, really easy to work with that. And then we actually have the update, which has the stream and this data. So let's go through and write out our main. This is the endpoint from Binance that we can actually stream our trades data from. We're going to be doing it on Ethereum. And so now we need this WebSocket stream connecting async from that URL. If we do get one, then we're going to split that stream into a reader and a writer. We don't need the writer in this case. We don't need to actually write data back to Binance. So we're going to go through it, and we're going to make sure that everything is in 1-minute bars. So we need a bar interval in terms of nanoseconds, but it's a minute. We need our current bar start, which initially is none, and then a vector to store all of these updates. Well, we want that so that way we can make sure we have all the data for a rolling minute. So while we're going to be accepting messages from our reader, so when we get a message, we have to check, right? We obviously don't want it to be an error, but we have to check what we have to match what that message is, and we're going to be doing that after we do some stuff with timing again. So we need now the current timestamp of the moment. We need it pretty much as a rolling clock is how I like to think about this. And then we need to get the timestamp, that clock, as nanoseconds. So now we can get our bar start, which is that timestamp where we are right now, over a minute in nanoseconds times a minute in nanoseconds. This will give us 1-minute intervals to be able to use in our loop. Because now, when we actually get messages up here, we need to match it and make sure that we handle everything correctly. So to start easy, we have an error, we're just going to log the error. If we have a close, then we're just going to log that we closed the connection. If we get a ping, a pong, a binary, or a frame, we don't need to handle that right now. Just an internal tool. If you were to actually do something with this, probably want to handle it a bit better. But regardless, we're going to go through now. And then if we have an OK message, OK text, OK payload, that same thing that we get from Binance, then we're going to be doing some further checking in that message. So we want to get its its event type, right? If we remember over here, its event type, we want to make sure that's a trade. That is really useful for if you want to stream two things at the same time. Like if you were to come up here, and I'm not going to do it right now because I would mess with my control Zing, but if you wanted to add aggregate trades, if you want to add the order book, something like that, you would be able to. It'll let you stream two things at once. And so then you would just have to match the message differently. So from that text, you can use Saturday JSON, and we can get a book stamp in terms of the update. So it'll have this populated data and the stream that we have, which is awesome that Saturday is this easy to work with. So we're going to store that current payload that we have. And so that way, if we can't process a bar yet, we just keep on populating our data, and then we can actually process a full 1 minute bar. So now we have to actually do some checking. So this line right here is really checking if we have a previous bar, because that should be that will be false at first. And so if we don't have a previous bar, that means that we just have a start. That means this is where we're starting. And so we're going to check if we have a previous bar. So if there's not the first trade, pretty much. And then this if statement is detecting if we have a new bar or not. If we do have a new bar, then we can get our footprint bar from calling this function on these current timestamps, on a reference of these current timestamps to keep the borrow checker happy. I'll talk to you guys more about what that is in a moment. And then after we process it, then we can clear it, because that way we can get ready for receiving new data. Then we're just going to print everything out. We're going to print it OHLC, OHLCV, and then the whole footprint stuff. Next, we need to update the tracking to the current bar. This is for the next iteration, right? Because it is a while loop. So now we need to tell it what bar we're on, pretty much. To continue through, let's make this function right here. So we're going to be populating this data structure right here of a footprint bar. We're going to have an open, high, low, close volume, and our footprint data is going to be known as a string. And you're going to see why in a moment, because again, Saturday is sick to work with. So if we don't have anything in this vector of book ticker updates, then we obviously just want to return that we have nothing. There's nothing for us to do. It's pretty much error handling. I kind of want to just get rid of this huge error. Okay, cool. So now, why are we passing a reference in here? This is a little bit of Rust stuff, right? Right now, the ownership of this vector is here. It's here. And even after I call this function, I still need to modify this vector. Now, what if this vector gets gigantic? I don't really want to be copying over or cloning the whole memory that I could have. I could have a lot of trades in there. I don't want to be cloning that on every single iteration. So I'm just giving it a reference to the current timestamps. In Python, we don't have to think about this. In Go, you do, but less. And so this basically tells the code pretty much that the ownership of this vector will stay here, but this function needs to know where it is so it can access it. So now we have this vector, and now we can go through and actually start populating this kind of data structure. So we need to make a new hash map, which is going to be the level and then the bid and ask sizes for it. And that is going to be a new hash map. First price and the last price, that is per bar. That's pretty much open and close. And so then we can keep track of high and low, right? Initializing high and low, which is the first price, and then total volume is going to be at 0 at first, of course. So now, for every stamp in the book, I'm just going to keep going so that way that error goes away. For every stamp in that book, we're going to go through and we're going to process it. We're going to get the price, which is p.parse. Our size is our quantity.parse, and we need them as float 64s. Because it's really, really, really common to have fractional stuff, especially for the size in crypto. And so now this M, if it's a market, here we go. I gave myself a good note right here. If this is true, the buyer is a market maker. It's passive, so the seller was taking is a market taker, and if the M was false, then the buyer is a market taker aggressive, and the seller was a market maker passive. So if the market maker initiates the trade, that's not how I want to say that. If the buyer is a market maker, that likely means that the seller initiated the trade. If the seller is a market maker, that likely means that the buyer initiated the trade. So now we can see who initiates it, and then we can know who, because when we know who initiated it, then we know what the trade actually was, if it was a buyer or a seller or not. This is what we attempt to do in order flow trading in markets when we only have, like, when we don't know who bought it. That's when we use trend and regression to try to tell it from our bid-ask sizes. There's videos about that on this channel. That's when we use that stuff to try to tell who initiated it. That's an estimate. But here we have a pretty damn good estimate by knowing who was aggressive in the trade, who likely is who initiated it. So it is an estimate from this sense as well. We got to keep track of our high and low. So just check if we need to update our high and our low or not. Scale our size. And then the price key, we're going to format it out to 4 decimal places, is our price. So then the entry to our footprint map is that that price key, right? So now we have this price key, and then we have this tuple. And so then we need to initialize it, which is 0, 0. And then our sell side, scale it by the size, or our buy side, scale it by the size, depending on our market maker. So now footprint JSON is Saturday.toString, awesome to work with. And then we can just set that into our data structure, and we're home free. Less than 200 lines to do that. So if we open up a terminal, we can just say cargo run, compile it. Now we can be running, and I don't know what the clock is. It might have, if it just turned 11, we're gonna have to sit here for a minute and wait for some data to come in. There we go. So it kind of looks a little ugly, but we can see we have a footprint bar, timestamp our close, open, high, low, close, our volume that we tracked, and then our footprint. So we can see at this level there was no sellers, right? Because that comes first. Let's go down here. Okay. I'm sorry, entry at 0, buy side. So there was no buyers and just that much size in selling. Here, the scale was a bit higher. All right, we just go through and we can tell at every level what the activity was like. Here as well, way more buying than selling pressure. So we can see how the volume gets spread out over an entire bar. And what side it was, which is pretty damn useful. I don't know why that's so. There we go. Let's watch another one come in. I don't think I've been talking for that long. Do I have to? Oh, I do have to. Sick. This is our cargo run. That was just that was me turning it off before, making sure it was good for me to make the video. All right, then we have another right here. Our open, our high, our low, our close, and then our current our volume of that bar, and then again this much on the buy side, this much on the sell side at that price level, and then later on, this isn't sorted. That might be something I'd want to do later, is sort this, so that way the highest price is the first one, and then you can see here it's not matched up like that. But yeah, this is how you can get footprint data from the Binance API in Rust. Super, super interesting, super useful, super straightforward. I've been doing a lot of thinking about how all of programming is really just a few concepts just abstracted in different ways and used in different contexts. And I have to think about it more. I'm planning on doing a video about it eventually. But the concepts that I narrowed it down to is looping, intervals, and just data structures of storage. And it's one of those things. Is like, well, like, yeah, duh. Like, what else is it? But then it's like you think about it, it's like, okay, Now it's like, which one of these n amount of tools should I use to solve this problem? So then it's like, okay, I should pick this tool. What things exist inside of this tool for me to do this? And it's like, okay, I know exactly what I need to do then for this. Is kind of the method of thinking that I've been having. So yeah, I want to make a video about that eventually. And matching algorithms, looping, aggregating data, right? Things like this. It's like, okay, I'm making this project and I got to this point and I need to continue it, and I need my continuation to end up like this. What actually is this? Am I aggregating data? Am I matching data? Am I looping through it? And it's like, okay, well, I'm matching. How am I matching it? I'm doing a bunch of string comparisons, and I need to do different things at each level. It's like, okay, first of all, let's compare the strings, and then we'll figure out what we need to do at this level. It's a method, a mental model of divide and conquer, right? It's pretty much all it is. But yeah, that's the video. Check out my algos in collaboration with Lux Algo. Use that code before the end of the month. If it is after the month, just sign up for them regularly, right? Yeah, you guys have a great day. See you in the next one.